you don't have to leave Platforma anymore because you could find everything in there to run your analysis from data into insights.
That's our goal. You cannot pick like an average study from nature and say everything which is there you can do yourself in Platforma. That's not the case yet, but that's our main, and we are really going very close.
Hi there, and welcome to the Repertoire Room. My name is Sander, co-founder and CEO at ImmuneWatch, an immunoinformatics company specialized in T-cell receptor sequencing analysis. And a couple of years ago, I got completely obsessed with T-cell repertoires, and I know that I'm not the only one. So in this podcast, I want to have insightful conversations with people that share this passion and discuss T-cell sequencing technologies and analysis. And in this second episode, I'm joined by Stan Poslavsky, CEO and co-founder at MiLaboratories. Welcome, Stan.
Thank you very much, Sander. Great to be here.
Thank you. So one of the first questions I would always like to hear is a bit like, what's your origin story? How did you end up in this whole repertoire field?
It will be unusual because actually by training, I'm a physicist, and I was studying physics and working in physics for many years. I worked in theoretical physics. I worked at Large Hadron Collider, so actually worked in the institute as a scientist in theoretical physics for 10 years. And and then actually my best friend, Dmitry Bolodin, is also a co-founder of our company and CTO right now in our company. We studied together. He studied biophysics. I was studying theoretical physics. And our first project that we did was about computer algebra, tensor computer algebra. We did programming in like computer algebra stuff, and that was super interesting. And then I went to quantum field theory. He went to biophysics, and then from biophysics to T cells and B cells. But we continued to brainstorm together things in programming. And at some point, he attracted me very much with the algorithms for processing sequence and data. Because actually there is a lot of mathematics behind those algorithms. There are many common things in the kind of mathematics that I was applying in physics, and the kind of mathematics that you need to apply to write really high performance algorithms in bioinformatics. So, and more, like on the one hand, you have Large Hadron Collider, that's the most beautiful machine in the world, but you don't see the outcome of this in real life. It's very interesting. And on the other hand, you have T cells and B cells and like new drugs and new therapies that are appearing today in your life, as an outcome of your research. So like at some point I shifted from those like mathematical things to more practical things, more and more, year by year, more and more. And at some point, like zero physics, 100% T cells and B cells. So that's it. But I don't have biological background at all. I never read a single book in biology.
Yeah, okay. That's indeed an interesting take. So from CERN to T cells, B cells. And indeed, it makes me wonder, like the mathematical world, the physical world, compared to the biological world, it's like more famous to be more noisy. Can you handle that, all this noise?
Well, you have to handle if you just want to live, because in the real life, when you interact with people, you have a lot of, it's non-strict thing like the mathematical theorem. So when you switch to biology, you just, it's easy to use to, given that you just live in the world. But I miss the mathematical, like, it's very, very strict. And you know what you're doing, theorem, step by step. There is no like something fuzzy around. Yeah, but it's fine. It's interesting.
Both are interesting to look at. I agree. Okay, cool. Yes, up next, how did MiLabs then get started? You already briefly talked about, indeed, your interaction with your co-founder, but what did the early days look like at MiLaboratories? What were you initially trying to solve?
Mm-hmm. So, we started in academia, and we were doing this academic research with our first software, MyXCR. Well, historically, we first implemented the tool called MyTCR for T-cell receptors, and then MyXCR where X either T or B cell receptor. And many people ask what MyXCR means. I don't know. I know that XCR means either TCR or BCR.
I didn't notice. I didn't notice. I think this is
Yeah,
gold.
yeah,
Like, yeah, that's
yeah,
interesting.
yeah,
Okay.
yeah. And the most once you ask me what's the most common question our users ask, that's how to pronounce correctly MyXCR. That's the most frequent question. So yeah, and we were doing science. We were building MyXCR because at that moment, actually, it was 2015 when we published in Nature Methods. That was a period when the next generation sequencing was becoming a real instrument in the immunology for the T cell receptor and B cell receptor sequencing. And given that the algorithms that for, let's say, even the alignment of the sequencing data that were existent before were designed for Sanger data, where you don't have that scale of sequencing information, and the speed was really, really poor. So we were designing those algorithms just out of our curiosity and because we had the data in the lab. We worked with other co-founder of our company, Dmitry Chudakov. He is a very well-known scientist in academia. And we had this data, so we had to analyze it. And we were doing this software just to, well, help ourselves. And then for a couple of years, we were doing this academic research. And since the field was growing, more people, more companies are doing T cell and B cell sequencing. At some point, the scale of support that we had to provide to our users and the scale of support that we have to provide to users in the industry will organically push us that we should make a company out of this, because more requests, more interest, more things we can do in a different pace in business when you're in business rather than when you're in academia. Yeah, because in academia you have grants, things are progressing slowly. You can't just hire like 10 people, it's impossible. So at some point we decided that it will be beneficial for the product, for the software, and for ourselves, and meaning how much things we can do to found the company. So in 2021 we started as a business and opened our startup.
Yes. Okay. Interesting. So indeed, a transition from academia to a startup company. A main reason being that more and more companies are getting involved in this kind of analysis, and you feel that they need some kind of different support, or maybe also some kind of different features added to the tool.
Exactly. To support the demand of the industry, and not only the industry, but just the demand of industry and academia in the software for dealing with this data. Well, you can't manage this demand in academia. Yeah, if you want to expand, well, and we feel that we can do this. We have everything to build this with all our experience and with all what we did in past. So we transitioned to a business.
Yeah, I can imagine. I've been trained as a bioinformatician myself, and there were a lot of tools that during my career that I actually encountered where support was completely gone because of the grants terminating or people not maintaining it anymore. Like this graveyard of cool bioinformatics tools that actually exist because people don't have the motivation anymore or moved on. And this is also one of the things now you can, as a company, hopefully you can actually be a little bit more consistent in keeping everything up and running.
100%.
Okay, cool. And for those less familiar, I think the company has evolved a bit since 2021. So you had MyXCR first, but what exactly does MiLaboratories do today?
So our main product today is a software called Platforma. And the idea of Platforma is that it's actually a software platform designed for biology users, because at the end of the day, well, there are bioinformaticians and there is a world of bioinformatics, and there are biologists. Yeah, biologists are people who are actually planning experiments. They know what they're doing. They are designing the studies and they are doing the science actually to get the understanding of what's going on in the biology. Yeah, and like they are biochemistry sequencers. They are talking with patients, with doctors, etc., and they want to, and they are presenting the final result. They are understanding this. And in my understanding, before I started to work in this field, bioinformaticians were people who are developing the algorithms, like myself. I was developing the algorithms, complicated algorithms to understand the data, package those algorithms into tools, and provide them for use. And then I realized that there is a huge gap between those tools developed by bioinformaticians and biologists, because biologists cannot run those tools. It requires resources and computing. It requires understanding the Python, R, instruments to do, well, some things that people working in hospitals, for example, are not trained to. And there is a gap, and there is a huge cohort of the bioinformaticians that are doing like literally monkey job of just running tools for biologists to get the results. And that's and we observe this a lot in our users. So this like a thing that we can solve with our software, with Platforma, and that's what we're doing. That's a software designed for biologists to get a really deep insights and to find the answers on the questions that they have to the data themselves, without bioinformaticians at all. Yeah, who are just running the data. I mean, not the bioinformaticians who are developing the algorithms. Yeah. So, and this is a platform which has various tools in the platform apart from MyXCR. Of course, we started with MyXCR because many people use it, etc. But now we have many things in the platform, and the whole idea of the platform is to give this interface for the biologist to get, with just buttons and clicks, easily what they need from the data.
Yeah, that's also an interesting evolution, right? You're actually moving away from just developing your own specific solution like MyXCR into like more platform, yeah, Platforma, of course, where others can also host their softwares and tools. Like you have these block features, and ImmuneWatch Detect, our tool, is actually a block in Platforma. Why is that exactly?
Well, it's actually super simple. In the real biological study, you have data, yeah, but then to get the answers from the data, you need many tools. In the real study, you need, well, dozens of bioinformatic tools to run to get like all layers of information from the data that you need to come up to the conclusion. Let's say if you do like bulk TCR sequencing, you need the clonotyping, then you need, I don't know, diversity, I don't know, gene usage, TCR specificity prediction, I don't know, HLA prediction, mapping against the databases, clustering, time tracking. And there are so many tools existing for those tasks that if you want to provide to the biologists the ability to go from end to end, you need to have those tools. And obviously you can develop all those tools yourself. So the only way is to make the existing tools available on the platform in a very nice user interface, which is integratable with all other pieces of information. So that's like organic thing, you know.
Yeah, it's really an end-to-end solution. Like you don't have to leave Platforma anymore, actually, because you could find everything in there to run your analysis from data into insights, right?
That's our goal. You know, you cannot pick like an average study from nature and say everything which is there you can do yourself in Platforma. That's not the case yet, but that's our main, and we are really going very close to that point.
Yeah. Okay. Interesting. Yeah. It also reminds me a bit like the initial focus, my TCR, then my XCR. Platforma is also, I guess, initially launched for repertoire analysis, BCR, TCR analysis. But I'm also thinking or hearing that you want to push this farther and also go into other NGS.
Yeah, and we already have like bulk gene expression analysis with all the standard things that people are doing, like gene expression, differential gene expression, pathway enrichment, I don't know, functional analysis, things like that. We have right now the full set of standard single cell stuff with dimensionality reduction, clustering, I don't know, cell type annotation, cell browser with many different things like CellXGene stuff. So we are covering more and more things. Multi-omics, when on the same t-SNP plot with cells, you can see your TCRs. Yeah, and that's automated in Platforma right now. So yeah, and later we will go to the microbiota. So we see that people are doing this a lot, and then other omics, of course.
Yeah, I just wanted to ask you indeed, like, because my background is trained, I was trained as a microbiologist and a bioinformatician in microbiome research. So my next question was going to be, when is microbiome on that list? Because I think this is also a valuable tool for that whole field. I think one of the reasons I switched field as well is because I see the overlap in tools and the way things are analyzed between T-cell repertoires and a microbiome, or a list of microbes coming out of microbiome studies.
100%, and the tools are very similar. If you know Metaplan, the tool for, and it's like when I see it, it's very similar to MyXR, for example. I mean the algorithm, how in general works. So it's very close. And since more and more people are doing this, we want to bring this to the platform. So in our roadmap, well, actually we need to finish with single cell multiomics integration. Then we need to do other things like site-seq ataxic, but that's pretty understandable. And then the microbiota. So that's our roadmap.
Okay, super interesting. I'll be following that closely and also announce that to all my microbiome friends, because they might not listen to this podcast, but I'm sure they could make use of these kind of tools. Okay, cool. And back to T-cell repertoires maybe a bit. You said before already you're not trained as a biologist, but I do believe you've seen plenty of repertoires pass by your fingers. What do you think is one of the biggest misconceptions that the researchers have when they start with like a T-cell repertoire analysis?
It depends which kind of researcher. If we talk about biologists, then the biggest misconception about the biologists is that the more the better. Let's put it this way. And I'm biased. I'm biased because I'm always at the very beginning of the analysis pass. We are on the upstream analysis from FASTQ files to the clone types with MyXR. So talking about this part, all my interactions with the biologists, well, not all, but many of the interactions with biology people was, we want to see more clonotypes. More. And when you do sequencing, there are so many things in the technology of next generation sequencing which lead to, well, wrong clonotypes. There are sequencing errors, there are PCR errors, etc., etc. The data quality plays a crucial role. And at the end of the day, like, why MyXR is successful? Because it really provides you the truth. Exactly what are the clone types there, they will be reported, not the errors, PCR errors, or sequencing errors, etc., etc. And from all interactions with the biologist, there was always one push: give us more data. Doesn't matter. It doesn't matter. It doesn't, but it matters. The garbage in, garbage out. And with MyXR, we have like the best quality of the results, which you can trust. And this, like, what people in many cases do not appreciate. They do not understand that this is actually good. They say, can you turn off this step, clustering for or PCR error correction? Then we'll have more clonotypes. Yes, we can. You can, yes, but then you will have wrong results. So that's one thing, and that's on the scale of the biologist, the quality of the data, and not really like taking care about the quality of the data. And the second one is about the bioinformatics. Bioinformatics, they always think that it is easy. That's the like the super big misconception. They think that boom, 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 this tool, and then wow, amazing results. Done. It doesn't work that way. You need to go very, very deep. This data is very complex. The amount, the T cell receptor, the rearrangement, and the biology behind, and like even if you apply the statistics to this data, it's very complex. There is a group in France, a very nice group that are applying mathematical statistics and statistical method to TCR, for example, to calculate the probability of the arrangement and things like that. And the mathematics behind is very complex. So you don't never think that this data is easy. You apply tool and you get the result. If you are doing as a bioinformatician a research in the data, that you need to go to the data.
Yeah, these are interesting insights, and also interesting that you are able to actually already distinguish between these two groups: the biologists that might be Platforma users and the bioinformaticians that might be MyXCR users. Each of them have their own challenges and their own misconceptions. Yeah, interesting, cool. You already mentioned one of the most frequently asked questions is how do you pronounce the name of the tool? Is there anything else that's on top of that list?
Yeah, well, uh, well, to be honest, this is the top one with a huge gap. Yeah, and the other questions they are very diverse. Well, like well, the second most popular is the following: I have my data. Please tell me what should I look for.
Mm-hmm.
Well, yeah. So that's still the case in there is a large fraction of people that are not really well understand why they are doing sequencing and what kind of information they can get. So still in the world of immunology, and I recently was on the IUS Congress, there are so many people that are not applying NGS. NGS provides you so much data. Yeah, not applying NGS because there's still like not a clear understanding where to look at and what you can do with NGS. You can do a lot, but what specifically, And at the end of the day, majority of like the bulk of the biology people who are doing T-cell sequencing, what they're looking for, what they're looking for. How do you think? They are looking on the number of clonotypes. That's it.
Yeah.
That's it.
Yeah.
Diversity, clonality or diversity.
Yeah, this is one of the weirdest things that I found transitioning into this field, that people actually summarize this huge amount of data into just one single digit that they just like, and then spend and then use that to confirm their hypothesis, while the rest of this data is just completely thrown out. It's like further insights are not used. Okay, I of course get it. You have to simplify things. It's a huge data set. You need to get insights in there. But this one number, diversity, to rule them all, I don't think that's really the case.
Yeah. But it's actually gives us a lot of opportunities because it will change. Obviously, this is changing, and like people, it actually the proof of the statement that people are just starting to do this kind of and to go into this direction. And then in the coming years, those tools like TCR specificity prediction will become like common. So we have good opportunities.
Yes, I agree. I think this is also one of the reasons that we want to push it farther with ImmuneWatch, like go away from these single digits outputs of the diversity and take a deeper dive. What is actually happening? What is changing, etc. I agree. Oh, that's interesting. Yeah. Also, I think for most of these people, more and more examples are coming out, right? More and more papers are appearing that show how they analyze T-cell repertoires, what kind of insights they used, and this can also spark new ideas on how they should design their experiments in the future. But this also gives me to my next question that I also like to hear from you is, yeah, of course, there's an impressive list of publications that have been using MyXCR. Is there one that really you think is one of the most exciting projects that you've seen that use your technology?
I can't name one, but there are a couple, and actually all those projects are related to the real drugs or therapies developed and now used by people. Uh, and this is like the most exciting stuff. They are public. Like one example is Neogen, for example. Yeah, they use they have a couple of publications. They use MyXCR a lot, and also our chemistry for the T-cell sequencing. Another example is I was when I saw that Ugur Sahin, that the founder of BioNTech, cites our software MyXCR in a couple of papers, which are very important for their vaccine. That was also like a big pleasure to see, like, so our software is used to develop this stuff. So it's very nice. And of course, COVID was a big boost to this kind of things. So there were like massive projects which processed like thousands and thousands of or like right now already hundreds of thousands of patients with MyXCR. That was done by CDC. That's the in US by National of Health. So those big projects were those huge databases for COVID data training and then understanding a lot of things, understanding what is exactly the reason of COVID, for example.
Yeah. Interesting. Yeah. Yeah, I think that's amazing. Like you had this first academic path, this tool had a big uptake. Indeed, COVID has been a reason why people also go more into NGS technologies. And as you mentioned in the beginning, where basically theoretical physics, it takes a while to see the fruits of your work. And here, okay, we can probably argue that it's the same for biotech, where people developing a drug is also not easy and also takes quite some time. But then seeing these research results with your tool, I'm sure it can make you proud. Cool. You also touched upon this a little bit, but you were at a conference in Vienna. A lot of people are not using T-cell technology yet for their immunomonitoring or their immune applications. So how do you actually see this field evolving, like this TCR sequencing in general, or the analysis in the coming years?
Well, it will like with gene expression analysis, like many people, it's like a standard, a commodity thing. If you do whatever type of the drug discovery, or understanding your patients, what's the difference, etc. You're doing this. Same will be with T cells. So it is becoming more accessible. Recently, 10 years ago, the whole technology of how to sequence the primers, like because you need to do amplicon sequencing, it was complex. Today, it's easier and easier. So the entry level is lower and lower. And what I saw on the conference on IU is that many people want to do this. They did not do it yet because they didn't start to do it yet because it was complex. The chemistry, library preparation. They are biologists. They think about these things. We're bioinformaticists. We get a FASTQ file, then you click the buttons, code, etc. But they need to do the lab work. Yeah, cells, all the things. So and now it's easier, and they really looking forward to start doing TCR sequencing to get that number with the diversity.
No, I'm sure they might want to push it farther a little bit now with the new technology coming out.
Absolutely. And with the tools like Platforma, which make the analysis the second part. Once you generated the data, you can go deeper, make it easier for them.
Yeah, I agree. Cool. I have one final fun question for you. I think I might know the answer, but I'm curious whether you would whether you would answer something different. But what would you be doing if you were not working in the repertoire field now?
So, well, I was a physicist, so let's ask question what I would be doing with if I am not a scientist, Then the number one pianist.
Really?
Yes, I play piano. Number two, I play very bad. So it's you have something. So I had to work in physics and biology. So I play very bad. And the second, if not pianist, then a cook, like a chef in the restaurant. That's my passion.
Okay, that's nice to hear. I'd love to get invited at your house one time to enjoy piano and a dinner, if that's open.
Absolutely. Come here. I'm right now in Bilbao. I live in Basque Country. This is the place where people really like to eat very well. So we have good quality of things here, and I can cook nice things.
I can imagine good quality ingredients. Eating is a part of the lifestyle. Like, cool. Nice to hear that. All right. Stan, where can people find out more about you and MiLaboratories if they want to connect?
So number one place is just platforma.bio. Simple website. We have that's the main site of our company. It's the site of our product. That's the number one. And then there we have all other links. So basically, that's a number. Where there you can easily download the software, which is free for academic research. At least it's a totally free download. You click the buttons, and you go from your data to your insights.
Cool. or at a local conference, they might find you as
Yeah,
well.
local conference. Well, yes, I know we have a schedule of conferences that we are going to participate, but sorry, I don't know yet which.
Check the website. It's probably on there. Okay.
Yeah.
Stan, I really enjoyed this conversation. Thank you so much for taking the time to talk to me, and I'll see you around.
Thank you very much, Sander. Pleasure to be here.